For constant acceleration, you can calculate the final velocity, Vf, if you know the initial velocity, Vi, and acceleration and time. So this is an important equation. Vf equals Vi plus acceleration times time. So reading the following, or this question. So a plane starting at rest, at one end of a runway undergoes a constant acceleration of 4.8 meters per second squared for 15 seconds before takeoff. What is its speed at takeoff? So initial, 0 because I'm starting at rest. Acceleration, 4.8 meters per second squared. 15 seconds is the time. What is this? My VF. So VF equals VI plus A times T, delta T. Plug in my numbers. Sorry. So it should be 0 plus 4.8 meters per second squared times my delta time. So 4.8 times 15 equals 72 meters per second. A car accelerates from rest at a constant rate of 2.3 meters per second squared. How long would it take the car to reach a speed of 15 meters per second? So I know it's worded a little differently. So constant rate, meters per second squared, that's going to be my acceleration for this. Trying to reach a speed, so 15 meters per second is my final. Starting from rest, meters per second, 0 meters per second. How long would it take? That's my time. So it's Vf equals Vi plus A delta T. I am trying to find delta T, so I need to isolate this. So Vf minus Vi equals A delta T. Divide both sides by my A. So I'm left with Vf minus Vi over A equals delta T. So 15 minus 0 divided by 2.3. Should be meters per second squared over there. Just caught that. Delta T. I end up with 6.5217 dot 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 2 sig figs, so 6.5 seconds. For constant acceleration, you can calculate delta x if you know the initial velocity, time, and acceleration. So this is another equation, a little bit different. You just got to know what you're looking for, or what you're given in the problem. I'm sorry, I misspoke. This is the last one, I swear. So a plane starting at rest at one end of a runway undergoes a constant acceleration of 4.8 meters per second. For 15 seconds, so delta T right there, hello, before takeoff. How long must the runway be? So how long, so you know it's how long is like time, but read the rest of it. How long must the runway be? So delta X, before the plane can take off, for the plane to take off. So we're starting at rest, so that's good. So that makes it easy on us again. So 0 meters per second. How long must the runway be? So notice how we're only given a VI, an A, and a delta T. So delta X equals VI times delta T plus half A delta T squared. Don't worry, you're going to be given these. You just have to learn how to recognize them, and I'll do my best to help you do so. Delta X. How long must the runway be? So no, I'm going to do something right now that's maybe a little confusing, but I'm going to scratch this one out. I'm going to make it a different color so you can see it clearly. So why did I scratch that out? Is because VI is 0, so 0 times anything is 0, so it's already gone. I don't have to worry about it. Now I just got to focus on I do it this way actually. So I'll put 0, then exit out like that, so I know it's 0. So half of my acceleration, so 4.8 meters per second squared, times delta t, 15 squared, 15 seconds squared. How much is what is my m? Or sorry, my delta x. So it says half times 4.8 times 15 squared. So I ended up getting 540 meters. So really quick, how did I get this? Well, if you look at this, we're just going to focus on the units for now. So it's meters over seconds squared. Then I'm multiplying it by something that is seconds squared. It's not over anything it doesn't say it's over anything, but we can assume it's over 1 because s squared divided by 1 is s squared. So when I multiply across, my units actually will cancel out, and all I'm left with is meters. So my answer is 540 meters. That's how long it must be in order for the plane to take off and all that type of stuff. Okay, I know that was a long lecture, so this is the end. Hopefully you followed along. We'll work on this in class. So take care.